Hey, Statistics Sifu here. And I've got a video for you that's a little bit different than what I had actually planned to put together. This video was supposed to be another example of how you can use ChatGPT to perform statistical tests that you do in SPSS in Python, or to use ChatGPT to help you figure out how to do it or to teach you how to do it. And it turns out that doesn't always work as well as we would hope, at least not with ChatGPT 3.5. I don't have access to ChatGPT 4.0 yet, and my hope is that that one will work a little bit better. But in any case, I wanted to show you an example of one of the common tests that we do in statistics, the chi-square test for the analysis of the relationship between two categorical variables. If you're not familiar with the chi-square test, or certainly if you're not familiar with the chi-square test in SPSS, please refer to the video that I put together that walks through that. I'll put that link in the description. If you're already familiar with the chi-square test, I think we can jump right into it. So I've got SPSS open right now. This is an extract from the General Social Survey. It's from 1988. It's just a subset of the variables. Again, if you haven't watched my video on the chi-square test in SPSS, I go into the full detail explaining every step. I'm not going to do that here because that's the purpose of that other video, but I will touch on a few of the key points. So again, this is for the analysis of two categorical variables. So I've picked two variables here. We've got one variable here, labor force status, and if you click on that, I'm in the variable view here, you can see that labor force status takes on 8 actual values from working full-time code 1, working part-time code 2, etc., down to other in code 8. There are 2 additional codes, 0 and 9, which are actually missing data codes. And you can see that here. They're coded as missing data codes in SPSS. The other variable I figured would be a simple one to look at would be respondent sex. That variable's name is just sex. Labor force status, by the way, is called workstat, W-R-K-S-T-A-T. Respondent sex is just coded 1 for male and 2 for female. So to run the chi-square test in SPSS is really pretty simple. That's one of the reasons why I recommend SPSS as a place to start if you're doing this kind of work. If we go to Analyze, Descriptive Statistics, crosstabs from the menu, I would recommend that you put respondent sex in the column. Usually we would put the independent variable in the column and the dependent variable in the row. So we're kind of looking at like what's the effect of sex on labor force status. So I'll put workstat here in the row. And then typically I change just a couple of the options here. Under cells, since I have my independent variable in the column, I want to look at the column percentages. I will also want to look at the observed counts. And then under statistics, I'm going to check off the chi-square test, which is the test that we want to run. And then typically we will also look at phi and or Kramer's V. In this case, it would be Kramer's V, but if you're running, if you want to produce those statistics, they get produced together. Anything that's not a 2x2 table would be Kramer's V. If it's 2x2, it would be phi. But so we'll only be looking at Kramer's V here. And those are the only changes that I'll make. I'll click on paste, and that will produce my SPSS syntax, which looks like this. I'll highlight that, and then I'll click on the run button. And that will produce the following output. And so we get here a contingency table. We could see we have 1,481 cases in the file, 638 male and 843 female respondents. And if we look at working full-time, we've got 63% of males are working full-time versus 38.7% of females. And then there are several other differences. So are there statistically significant differences across the sexes in terms of their labor force participation? Again, this is from 1988. Keep that in mind. And if we look at the chi-square test, you see we get a value here of 221.663. That's well above the critical value, 7 degrees of freedom. And we see our asymptotic significance less than 0.001. In other words, this is statistically significant. There is an effect there. This is always an important warning to look at. If you've watched my other video, we talk about this quite a bit. 0 cells have expected counts less than 5, so we're clear. Everything's good there. And then if we look at our symmetric measures of association here, Kramer's V, 0.387, that would be very strong. Anything above 0.25 would generally be considered very strong. Okay, so that's the test in SPSS. And the main reason I run that is just so that, I know what I'm looking for. Now, there's two different programs that I've talked about using ChatGPT to assist us in learning how to do what we already know how to do in SPSS in R and or Python. And so let's look at R first, because this is a statistical test. And of those two programs, R in particular is very well suited for running statistics. Python can run statistics. It's not really specifically for that. It's frequently used for it because it's such a versatile, powerful language. More than just a program, it's actually a language. But let's take a look at how we can use ChatGPT to help us duplicate this same procedure, which hopefully after watching this, you go like, oh, that was pretty easy to do in SPSS. And hopefully it'll be similarly easy to execute that in R. So I've got RStudio open here, and I've just got it's ready to start. There's really nothing in here. But let's say I don't know how to code this. Without knowing how to code it, there's really nothing I can do here in R. So that's why I'm going to go into ChatGPT. So here's ChatGPT 3.5, just open here on my web browser. This is something we're going to look at again. ChatGPT can make mistakes. Consider checking important information. Okay, so just keep that in mind. It's not perfect, especially 3.5, but even when it's not perfect, it can be very helpful. So let's use this tool to help us learn how to use R. Now, the first thing I need to do is read my data file into R. And so this is just my Windows directory, and I've saved a copy of that SPSS file as a CSV file here. And CSV files are pretty easy to port around the different programs, very easy to import into both R and into Python. So if I want to just get the path to this, you can actually just right-click on it, and you can say, copy as a path, and that'll allow you to paste the path directly in there. So the first thing I'm going to want to ask ChatGPT is read in, or generate the R code to read in the following CSV file. And so I'm just pasting that that path. And so ChatGPT is taking care of all the little specifics of doing this. I can copy this code. I can go back over into R. I can paste it. And just like when I was pasting SPSS syntax, right? Highlight it and I hit run. And you can see it read it in. We printed out the header so we can see it. Now, an important thing to note. It read in the file, but it didn't read in all that metadata. One of the really nice things with SPSS is you get all those descriptors, you get the values, right? So that you're able to work with these numeric codes, but then also they've got labels attached to them. None of that was read in here. All we have in the CSV files, like the very raw file, we've got the variable names, and these align with the variable names, not descriptions, but names from SPSS. And then we've got the numeric codes. And in the old days, we typically tote around a code book. So you could see, well, what does sex equals 2 mean? What does sex equals 1 mean? That's the easier of the two to remember, right? 1 equals male, 2 equals female. But those labels are nowhere there in the file. So if we want to show those labels in our output, we're going to have to include that in the code when we do this in R. So it's a little inconvenient, but it works. And similarly for work status, we've just got those codes 1 through 8, also 0 and 9, though we're going to exclude them from the analysis. But 1 equals working full-time, 2 equals working part-time. And if we want that to be expressed in our output, we're going to have to describe that in our R code or R syntax. So we can ask ChatGPT to do that. Now, rather than having you sit here and watch me type through, I've actually saved the prompt that I used to do this. And so I'll just paste that into ChatGPT so you can see how that works. So I've copied this from a text file. I'm actually going to have it give me the whole thing with the path because I want to make sure that it's addressing that specific file. So if I paste this in here, you can see the description. Create the code to read the following file into R, same thing we did before. Generate the R code to use the variables from this file called sex and workstat to create a contingency table, i.e. crosstab, with sex in the columns and workstat in the rows. Replace the numeric codes with the following labels. So again, because this is not embedded somewhere in that CSV file, we're actually telling it here. 1 equals male, 2 equals female, 1 equals working full-time, 2 equals working part-time, etc. Codes 0 and 9 are missing data codes, should not be or should be excluded from the analysis. And then we're saying produce output similar to the following SPSS syntax. ChatGPT seems to understand that, at least in part. That's basically the SPSS syntax we used to create the output that we did in SPSS. Make sure to include both observed counts and column percentages in the table. Perform the chi-square test and report the Kramer's v-value for this test. So I'm just basically explaining to ChatGPT what I want. I send the message, and then ChatGPT is generating the R code for me. It tells me this code reads the CSV file, recodes the variables with labels, creates the contingency table, performs the chi-square test, etc., etc. All right, so I'm going to copy this code. I'm going to go back to RStudio, and actually, I can replace all this here because it's just going to duplicate it again. So there's my code. I'll highlight the whole thing, and I'll run it. And boom, just like that, R has done the whole thing with just what ChatGPT produced based on my description. And you can see here are the counts. And actually, let me open up the SPSS output right next to it so you can compare them. I think the SPSS output actually is a lot nicer looking. So even though we keep talking about SPSS as a starting point so that you can use these other programs, it's got some advantages too, right? So if we look at working full-time male and female, we see the same counts, 402 and 326. We don't have any totals listed here. I guess that's okay. Working part-time, 48 and 118. So it's given me the proper counts, right? Other, 4 and 11. Yeah, everything lines up. If I scroll down here, now we've embedded the totals, I guess, in the calculation of the percentages, but these should also line up. So males working full-time, 63% versus females, 38.7%. Males working part-time, 7.5%. We're going out a few more decimal places, actually, but yes, everything matches up. So what ChatGPT gave us produced the same output in R that we had produced in SPSS. If we look at the test itself, your Pearson's chi-squared test, we get a chi-squared here, 221.66, so it rounded it off a little bit. We had 221.663, 7 degrees of freedom, and a p-value. This has got the scientific notation, whereas in SPSS they just said less than 0.001. But yes, statistically significant, right? At the 99.9% confidence level, there's less than a 0.001% chance of it just being random chance, right? Okay. And then we get a Kramer's v-value, 0.3868, which rounded is the same as 0.387. So it was that easy. Tell ChatGPT what you want, ask it to create the R code, boom, and you've got it, and you've run it in R. And now you've got an example. More importantly, you now have an example of, well, what does a chi-square test in R look like? So just save this as, save as chi-square test in R. And so now I've got my sample code, and anytime I need to do it, I can go in here. I just change the names of the variables. I change the labels however I need to change them. There's some other things you have to update, the number of categories, right? 2 and 8. It's all embedded in various different places. But for the most part, are really good at doing statistical testing. These procedures are all embedded already within the packages. And so there wasn't that much more you really had to explain. You just asked ChatGPT to run a chi-square test in R. So there it is in R. I don't want the video to get too long, so I'm going to stop here. And in part 2, I'm going to try to do the same thing in Python. See you back here in a little bit.